Introduce yourselves, girls. Okay, here we are. Okay. Come up and introduce yourselves. Okay.
I'm Jenna.
And Jenna, what grade are you in?
We're all grade 5s here.
Perfect. Okay. Right.
Okay, next one, and you must smile for the camera. Okay.
I'm Kiara.
Hello, Kiara. That's such a lovely name. I was going to call myself that when I was a little girl.
Yes?
I'm Melissa, and I'm the only one who's actually smiling.
You are indeed, and I've got lovely photos. And that reminds me, Mrs. G, I must send you all the photos and video from all the previous talks.
Yes, please.
I'll do that. Got you. Okay, so I've got some cool brain tricks for the girls, and maybe we can even try a magic trick.
Perfect. Then I can fit you on the camera in one shot.
Should we try the magic trick? We'll see if we can do it. You might have seen this one, but I don't think the girls have seen it. Let me see if I can load up the screen. Let's go to share screen. I want the girls to think of a number that is between 1 and 63. Have they got one?
Writing it down, girls? Yep.
Okay. And what I'm going to do is I'm going to pick on the first person. So who's sitting in front?
Kiara.
Kiara, you're going to go first. I want you to think of that number from 1 to 63. Do not tell me what it is. You got it? Okay. Now what I'm going to do is I'm going to attempt to share the screen. Let's just see if that's working. Where is my screen? Here. Let's go to share screen. And I'm going to go over here. Right. Can you see that screen in front of you?
Yes, we can.
Okay. Is your number on slide A?
No.
No. Okay. Is your number on slide B?
Yes.
Did you say yes?
Yes.
Okay. Is it on C?
Yes.
Is it on D?
No.
E?
Yes.
And F?
Yes.
Okay, so you were thinking of the number 54.
Yes.
Okay, who's next?
Me. Yeah, we have this on
Okay.
our iPad.
Have you got this on your iPad?
Yes.
But you know how it works.
No.
No, you know how it works.
Okay, so the next person must pick a number from 1 to 63. Do not tell me what your number
Yeah.
is. Okay. Is your number on A?
Yes.
B?
No.
C? So is it there? Yes or no? I can't hear you.
No.
No. Okay, no. Is it on D?
Yes.
Okay. Is it on E?
Yes.
Is it on F?
No.
You were thinking of 25.
Yes.
Correct. And last one.
Kiara. Right, Mel.
Have you chosen a number from 1 to 63? Okay. Is it on A?
No.
Are you still there?
Yes? It's not on A. Mel, maybe come up. Come on.
Can you see A?
Yeah, it's not on A, see?
Not on A. Is it on B?
Not on check for me. It might be easier. Let me move the webcam. Okay, is it on B?
Yes.
C?
Yes.
D?
No.
E?
No.
And F?
No.
You chose the number 6.
Magic, girls. Do you know how it
Is
works?
that correct?
Oh, that's correct. Three bullseyes there.
Not bad, not bad. But now let's find out how it works. You see, a lot of people have seen this on the iPad. They sometimes get them in the lucky packets during Christmas time. Sometimes people, they've got these little cards they get from a magic book. But the trick is actually very simple. But in order to explain the trick, I'm going to do a brain teaser with you, and I'm going to show you how the brain teaser connects to the trick. Okay, so now let me get my little draw pad. And I'm going to share the screen again. Let's go to share screen. There we go. Right. Imagine you go to a bank, and the bank teller gives you 63 1-rand coins, and she gives you 1, 2, 3, 4, 5, 6 material bags. You can't see into the bags, you can't see out of the bags, not that you would be inside the bag in the first place, and you've got 63 1-rand coins. You have to use up all 63 1-rand coins, and you have to put them into these 6 bank bags. I'm going to label them A, B, C, D, E, and F. How would you put those 63 1-rand coins into these bags? They do not have to be the same number of coins in any of the bags, but you have to use up all 63. And if I ask you for any number from 1 to 63, you'll give me that exact number. So for example, if I ask for 1, you'd have to give me a bag with 1 in it. If I asked you for 63, you would give me all 6 bags. So how would you arrange those bags to put all 63 coins in there so that you could give me any number of coins from 1 to 63 without opening up the bags and taking extra coins out or putting coins in? Does that make sense to you all?
Okay, got it? Right, work on that one. See how you're going to do it. Remember, you've got to have a total of 63 coins.
And the best way to solve it is obviously just to try something. So put some numbers in and make sure it all adds up to 63, and then we can test it out.
No, you can put the same number and you can put different numbers in. You just got to add up to 63. But whatever number we want, you've got to be able to. If I say I want 5 coins, you've got to give me a bag, either one bag with 5 coins or more than one bag that adds up to 5. If I say 6, any number I pull up between 1 and 64, you've got to be able to. 163, you've got to be able to give me. Obviously, if I say I want 63, you give me all the bags. But if I want 62, you've got to be able to give me 5 of them.
And what makes this trick so cool is that once you know how it works, you can actually go and drive your moms and dads crazy with it.
Because I gave you a hint there. Right? 63, you're going to give me all the bags, aren't you? 62, you can't give me all the bags. but you're going to give me 5 of the 6 bags. So that's a little hint. 5 of your bags have to contain 62. So you know what your 6th bag has to contain. That's the only hint I'm going to give you.
I mean, what we could do is we could take someone's working out already and we could test it and we could see what happens. So Jenna, have you got any ideas of what you would put in the bags?
No.
So why don't you throw some numbers out? Let me switch over to the other screen and you're going to throw some numbers out and we're going to test it. All right.
Okay.
Okay, how much should we put in the first bag?
You've got to put 9, you said.
Yeah.
9.
Okay, that means we've got 54 to go.
Oh,
The next bag?
6.
6. So now we've used 15 so far.
1.
1. So now we've got 16.
We got 16. Okay. 20.
You say 30.
20. 20. 20.
20. So that's 20. That's 36 so far.
11.
That's 11. That means we've got 47 and 63. To take away 47, what does that give you?
Pardon?
16.
Minus 47.
16.
Okay, so now, if I asked you, Jenna, could you give me R1, what would you do?
Pardon? Give you bag C.
Bag C. If I said, can you give me 32 Rand, what would you do?
Give you bag D, E, and C.
Correct. If I said to you, can you give me 8 Rand?
I can't.
You can't. Okay, so then we need to make some adjustments. So you can appreciate that obviously we can make a few numbers. We can make 1, we can make 7, we can make 10, we can make 15, we could make 16. We could also add 16 onto here to make 32. We could then also have 20, 11, and 1, which makes 32. We could make 31. We could make 12. We could make 17. We could make, there are quite a range of numbers, but we can't make all the numbers from 1 to 63. So I'm going to give you a hint. We're going to start this again. But now check this out. I want to see if you guys can spot a pattern. All right, 1, 2, 3, 4, 5, 6. A, B, C, D, E, and F. We have to put 1 in the bag because someone is bound to, and we can do 3. What number can we not make?
So we lost your sound there, Steve.
Oh, can you hear me now?
Yeah. Yeah. Okay. Now we've got the picture as well.
All right. So if you're looking at what I had before, let me just quickly go back into it. A, we put 1 in A, and we put 2 in B, which means we can make 1, we can make 2, and now we can make 3 if we combine A and B. What number can we not make?
4.
But now, if we put 4 there, we could make 1, we could make 2, we could make 3, we could make 4, we could make A and C, which is 5, we could make B and C, which is 6, and we can make A, B, C, which is 7. What number can we not make?
8.
Now we can make
a number.
a pattern. Can you see a pattern?
So what are the next 2 bags?
16.
32. So basically, with these numbers, we can make any number from 1 to 63. So let's try one. 48. Can you make 48?
Yeah, yes we can.
How? How, Mel?
We're going to an F and E.
E and F, very good. What about 31?
What is it? Figure. Oh yes. No. No. Yes.
31. How did you 31?
Oh yeah, E D A B C.
So A, B, C, D, E would make 31, correct. You all understand that? Because that's 7 and 8 makes 15 plus 16 makes 31. So now knowing that, let's go back to the slides again, and I want to show you something that you might not have noticed before. Okay? Let's go here. Going to go to Can you see my screen?
Yes, we can.
Okay. So what do you notice about the top left-hand corner over here?
So it's 1 day.
That's a 1. What do you notice about this slide here? What do you notice about this slide here?
4.
What do you notice about this slide here?
8.
And this slide here?
16.
And then what do you think the last one's going to be?
32.
So basically, the top left-hand corner of every slide is going to be your bank bag. All the other numbers are the numbers that you can make with those bank bags. So if I was going to make the number 10, which bank bags would I need?
D and B.
B,
D and B.
correct, which is 2. But notice, here is 10 on B. And if I go to C, you won't see a 10 there. If I go to D, you will see a 10 there. So then what I do is, if you tell me that your number is on D and it's on B, I add the top left-hand corner numbers of those slides, and 8 and 2 gives me 10.
There were your numbers, girls. When Steve was doing it with you, I was also working it out. And there are my answers. 54, 25, 6. And I added the corners of the numbers that you said it was on that card. Okay?
So let's try one.
that?
I'm going to think of a number, and you guys are going to have to try and work it out. Is it playing the PowerPoint now?
Yes, we can see it.
Okay. So now I'm thinking of a number, and it is on slide A. So what are you going to do?
1.
Add 1. It is on slide B.
Add 2. Add 2.
Huh?
It is on slide C.
Well, we can't. Okay, we can't see the sides, but we know what's in the corner.
Okay, all right. Let me just maybe it's showing you the other thing. So let me go like this. I'm going to go there, Alt Tab, and then I'm going to choose our share screen, be the actual presentation itself. Okay, can you see C now? Okay, now it is on C. It's not on D. It is on E. And it's not on F. What was my number?
Kiara.
23.
23 is correct. Do you understand that?
Yes.
Now, girls, do you know what we call those numbers that are on the corner of each slide? All right, think of when we did exponents in class. Little numbers in the air.
Oh, what's it called?
What are those numbers all have a common thing about them?
They each double each time.
They're doubling each time, so they're powers of what? Yeah, powers of 2.
Powers of 2, absolutely.
Yeah, and any number to the power of 0 is always equal to 1. So even 1 is part of the powers of 2. Catch it? Yeah.
So now here's what
We
you're going
talked
to
about that a
do.
little bit before, but we'll do that more next year.
You guys are going to email me at info@livingmaths.com, and I'm going to send you that PowerPoint, and you're going to drive all your friends crazy with it. If you want to, you
Wow.
can print it out. And we have Reinhard from Germany who's just joined us. Hello, Reinhard. How did your presentations go?
Very good, thank you. Can you hear me?
I can hear you clearly, yeah.
Okay, yes, we have just finished and just want to say hello before I get home now.
Oh, okay. So Reinhard students just want to say hello?
Yes, students have already left.
Oh, so Reinhard students don't want to say hello, but we do have Sarita. Hi, Sarita. How are you?
Hi, I'm great.
And
how about you?
very good, thanks. We have the girls here in Durban in South Africa. Sarita is all the way in Taiwan, is that correct?
Yes, it.
And Reinhard is
Sarita,
all
what
the way-
time of day is it?
Yeah, what time of day is it for you, Sarita?
Pardon?
What is the time there for you?
It's 8:50 p.m. in Taiwan.
PM. So that's not too late.
Right.
And for Reinhard in Germany,
So we have
That's
about
probably-
2:50.
2:50. So it's the same as us. Same as us here in South Africa. Okay, so I'm going to be giving the girls a brain teaser, and maybe you guys can help them to try and work it out. Sally, did we do the one with the 9 children last week?
No. Did we do the 9 children?
Oh, yeah. And 6 things.
No, I don't think we did.
Okay, all right. So this is a very nice one. There is a couple that have got 9 children. And I'll draw it for you because I think it's important that if you see it, it's easier to understand. So I'm going to go to share screen. Okay. And I'm going to go to clear here. Right. So here is a man and a woman. And they have 9 children. 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that the age difference between each child is 18 months. And then again, 18 months. And then again, 18 months, all the way to the last child. So there's always going to be 18 months between the person before them. Does that make sense to all of you?
Yes.
Okay. We also know that the oldest child over here, the oldest, and this one over here is the youngest. The oldest child is 5 times the age of the youngest. My question to you is, how old is the youngest child?
Whoa, there we go, girls. That's a brand teaser of note.
And now it looks a lot harder than it really is. My hint to you is, if you can work out the age difference between the youngest and the oldest, then it should be no problem to work out the ages. The girls still looked a bit stumped. I'll give you another hint. Let me draw it for you. Notice that 18 months is equal to 1.5 years. Maybe that'll help you.
What is the gap between the oldest and the youngest in years. Look that up. Look at your drawing. Remember, always a drawing helps because you can do the hops.
And this is why sketching your answers is so important, because pictures can help you to understand the problem better.
How many hops have you got, girls?
8.
Mm-hmm.
So
Okay, and that's 1.5 years each time.
Mm-hmm.
So how many years is it? Well, we've done fractions. Counting up in fractions.
And for grade 4, this should be no problem, especially since you're only dealing with halves, you're not dealing with anything fancy there.
Well, what are 8 1.5s?
4.
Mm-hmm. Well done, Jenna.
So, now let me draw that, Jenna. That was very good. So what you're saying is that the youngest is 12 years younger than the oldest. So whatever age the youngest is, the oldest must be 5 times their age. So in other words, if you said that the youngest was 1 year old, the oldest would have to be 13. Do you agree? Because there must be 12 years between them. But is 13 5 times 1?
No.
Obviously not. So
Okay,
let's
so come
try
on,
experiment.
use the Goldilocks method. We know 1's too small. Try something else. If it's too big, go
Some
in the
people
middle.
might even draw a table. They might go youngest, oldest. If the youngest is 1, then the oldest must be 13. And you can decide if that is 5 times that. Then try 2 and 14 and just keep going until you find a combination that works.
Got it.
Is it 3 and 15?
Say it loudly.
3 and 15. So the
Look
youngest
at
is
you,
3.
Brainy Box. What did you have for breakfast this morning? Brainy oats. Okay, let's have a look. We're going to go back to that one. And you'll see that according to your calculation, we know that there was a 12-year age difference. There was 1, 2, 3, 4, 5, 6, 7, 8 humps between the youngest and the oldest, and each hump was 1.5 years. So that would make 12 years altogether. And that means if we're looking at the table over here, youngest to oldest, if the youngest is 1, the oldest would be 13. And clearly 13 is not 5 times 1. If you then said that the youngest was 2, then the oldest would have to be 14, and that's 7 times, but not 5 times. And then, of course, Jenna said the youngest was 3, which means the oldest has to be 15, because there isn't a 12-year age difference. And 15 is 5 times 3, so that is absolutely correct. Do you understand that?
It's a good puzzle.
Okay. Now I'm going to give you one that will really, really put some chest on your hairs. It is a challenge and a half. Are you up for the challenge?
Yes.
Okay, so let me switch my camera back on. Where is the camera? Over here. Okay, so I want you to imagine that there's a restaurant called Wimpy. Ever heard of it?
Yeah.
Okay, and the Wimpy are having a special that when you buy 3 burgers, you will get them for 30 Rand. Okay, so
30
Sarita,
Rand.
you can just imagine 30 Rand for all 3. So Sarita, you can just imagine $30 for 3 hamburgers, which is probably expensive, but it just makes it easier if you work with a currency that you are okay with. So 30 Rand for 3 burgers. So 3 friends who happen to be attending a class in the afternoon, like you are, decide you're going to go and have hamburgers at Wimpy. And you take 30 Rand, you put it on the counter, and you get 3 hamburgers. And the lady says she'll bring it to your table. But while you're sitting there, all of a sudden the lady realizes, wait a second, today is Wacky Wednesday. you're supposed to get a special price. So instead of costing 30 Rand for 3 hamburgers, it's only going to cost you 25 Rand. So then that means she takes 5 Rand out of the till, and she has to return 5 Rand to the 3 of them. Does that make sense? Okay?
Yes.
So the waitress, she takes 3 1 Rand coins and 1 2 Rand coin, and she brings them over to the 3 of you, and she gives each of you a 1 Rand coin. So if you paid 10 Rand each and you got 1 Rand back, what does that mean you've spent? 9 Rand each. Do you agree?
Yes.
Okay. And Sarita says she's off. Bye-bye, Sarita. So you've each got 9 Rand that you've spent because you gave in 10 Rand and you got 1 Rand change, and there's still a 2 Rand coin. So you decide to give it to the waitress and you say, here is your tip for bringing us the burgers. But there's a problem. Because if each of you paid 9 Rand, 9 Rand plus 9 Rand plus 9 Rand gives you how much?
27.
27 plus the 2 Rand.
29.
Where's the missing Rand?
Oh.
Now, no one took the Rand. I'll say it again. You've got 10 Rand. You each have 10 Rand. So imagine you each put 10 Rand note down on the table right now. And then I tell you, no, it doesn't cost 30 Rand, only costs 25. So I put down 3 1 Rand coins and a 2 Rand coin. I give you that change. Is any money missing at the moment?
No.
No. You each take 1 Rand back. That means you each spent 10 Rand, but you got 1 Rand back, which means you each spent 9 Rand. No money is missing at the moment. Do you agree? And you give the last 2 Rand to the waitress. So 2 Rand plus the 3 9s, 9 and 9 and 9 makes 27, plus the 2 Rand, 29 Rand. Where is the missing Rand? Jenna, where's my missing Rand? Michaela, where's my missing Rand?
So no one took it?
No, no one took it. Or maybe I took it.
Mrs. G, you can't take our money.
There you go. This is going to be a problem. What are you going to do if you go to a restaurant and you think that they're diddling you? When your mom's come out, when you go home and your mom says to you, "Did you get any change?" and you give your mom 1 Rand, she says, "Okay, well you spent 9 Rand." Hello, where's my Rand?
I do find that the girls can relate. Often their parents will give them money to go and see a movie, and they'll say, "Look, here's 50 Rand. The movie only cost, let's say, 40 Rand." And then they come back and they go, "Where's my change?" You go, "What change?" They say, "But I gave you 50 Rand and it only cost 40 Rand." You're like, "I don't know. Maybe the money just disappeared." So maybe that's what happened.
You figured it out yet, girls?
No.
No.
I'm making my own money.
Oh, there you are. Melissa's cutting up bits of paper. She's making
Good
money.
move. So now you can
Make
see
a
where the
mock
money's missing. I like that.
The 3M method. Make a model method.
Miss Mama wants us to
Wasn't it a make a mess method?
Well, yes, that too, I'm sure.
So if you each make 10 Rand, then you don't have to make 30 Rand. Might go quicker.
Okay, Jenna, you better go because you're going to be late for. Jenna's got hockey trials.
Ooh, and you don't want to miss your hockey trials.
Oh. Okay, Mel's also. Have you got hockey trials?
No.
Okay, Mel and Jenna have got hockey trials.
Who does not play hockey in that class?
Kiara.
I wonder. So you're going to have to tell them the answer. Bye-bye.
Down a bit. Okay, bye, Jen. See you tomorrow. Hey, Mel, you can try this out at home with your bits of paper. Take your bits of paper home. Okay, try it out at home. Okay? Ask your mum if she can figure it out. Okay. Right. Laura, any ideas?
Will know the answer. Any ideas? It's a bit tricky, isn't it?
Yes.
Would you believe me if I told you that there was no rand missing? How could that be possible? There was no rand missing. So then what actually happened? Did you give up? Okay, so let's have a look at this one. All right. If we look at the numbers, we did all the correct maths except for one problem. When I got to 9 plus 9 plus 9, it's 27, and then I should have minused 2 rands. And that would have given me 25, which is what they paid. But because I added the 2 rand, it gave us 29, and then of course I asked you where was the missing rand from the 30 rand, but we shouldn't have been calculating it from the 30 rand. We should have been calculating from the 25 rand because that's what they paid. Does that make sense?
See. It's like this, Steve. Did you ever do this with your kids when they were small? I don't know if you can, let me try and, Kiara, come and hold this. So Steve can see me.
Okay.
Can you see my, we say to the kids, I've got 10 fingers. 10, 9, 8, 7, 6, and 5. Oh, I've got 11 fingers. Did your mom ever do that to you?
There was always this one here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And they always tell me, no, you've made a mistake. And I go, watch again. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then, of course, 10, 9, 8, 7, 6. 6 and 5 makes 11. So we've got 9 and we've got 11 fingers. That's a bit confusing.
Just the way we math teachers like to trick you.
I know we don't do it to trick you. We just do it because we enjoy watching you squirm. When we study to be teachers, that's one of the things. There's a subject called How to Make Your Students Squirm, and I think that we do quite well at it actually. Okay, are you ready for your next brain teaser? Can I give you a tough one?
Yeah, I'm going to
or an easy one.
Kiara.
Okay, you're going to come to that. Brilliant.
Okay, so we'll have the two of us working together. Okay.
Oh, this is going to be lovely. Okay, and you both got a smile. Let's see a nice big happy smile. Got you. Now we can put on police file. Okay. Let's see if you can do this one. Okay, I'm going to write it on the screen for you. Where is my little cursor? And let's go here. This seems to be working very nicely now. New. Don't save. Okay. A, B, 8, C, plus D4 is equal to 6,000 E, F, and the number 1. So now we know we have A all the way up to F. We have all the numbers from 1 to 9 represented. In fact, from 0 to 9 represented. There should be 1, 2, 3, 4, 5, 6, 7. There should be 10 digits, 10 single digits from 0 to 9. We have to use each digit once. And we need to find out which digit D, C, B, A, E, and F have replaced. Does that make sense?
Yeah, makes sense.
Okay.
Why don't you write them from 0 to 9 so you can cross them off as you use them? Okay, now cross off the ones you've already got. Okay, all right. Now think of this column here, because you're going to start with your units column. Think about what C would have to be to get an answer ending in a 2. Sorry, it's a 1. It's a 1. You've copied this down incorrectly.
Yeah. Oops.
Couldn't be a 2, otherwise you would use your 8. You would use your 8.
Correct. So this is supposed to be a 1. That's right. That's right.
Okay. What would that? Yeah.
7.
Correct. Now cross it off because you've used it.
But don't forget that if you did say that it's a 7, that means when you add 7 and 4, you're going to be carrying 1.
So you can carry 1. 8. And I think what's D got to be? Oh, now you've got lots of possibilities, haven't you? Because you've got 1 plus 8 is 9. You've got 9 and something is something. Okay, so what you need to do is maybe just try some of these numbers, and if they don't work, don't cross them off here yet. They don't work, because you've got to end up, think about this column here. Remember that whatever this is, even if you've got to have a carryover, it can't be too big, because it's not going to be 16, because there's no 1 down here, it's just going to be 6 on its own. Now you've already used up to 6, so this can't be 6 and nothing. So what do you think that A is going to be? How are you going to get your answer of 6?
Well, if you're assuming that, for example, it was 6,000 plus a 2-digit number, and you still got an answer of 6,000, the problem is you can't use 6 twice.
So what does that A have to be?
So maybe it's a number.
Look at this as a 4-digit number. It's 6,000 and something, plus only a 2-digit number. But this can't be a 6. Your answer is going to be 6,000 something. So what will this have to be? To get to 6,000 and something, because this can't be a 6. What's it going to have to be? Remember, you're going to add something onto this number to get your answer of 6,000 something. Correct. Okay.
Nice thinking.
Right. Now, how are you going to get from 5 to an answer of 6, sir? Good. You're going to be carrying a 1 here, not there, carrying a 1 here. All right, so don't forget that when you work out E, it's got to be a number that's bigger than 9. So that you
and just cross off all the numbers you've got. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We've used 8, we've used 7, we've used 1, we've used 4, we've used 5, we've used 6. Now we've only got a 9, a 2, a 3, and a 0. So if you did make D a 9, then what would F be?
18, but you've used an 8 already, haven't you?
Yeah.
So obviously
So
it's
D
not
can't. So try another number for D. D could be 3. Okay, then you've got 9 plus 3 is Could be that, because you haven't chosen the 2 yet. Okay, well, put that down. You can always rub it off later. Right. Okay, that would be a 2. It's 12, and then you've carried 1. So you've got the 1 there. Now, what numbers haven't you used? Well, you have, where have you used the 3? Oh, there. Okay, 9 and 0. So you carried 1. So what would this? You've got to use a 9 and a 0. E has to be 9, correct? Because 9 plus 1 is 10. So that would be your 0, and that would give you your carryover. You got it?
Yes.
Okay, so tell Steve what your answer would be. What your numbers would be.
A will be 5. B will be 9. C will be 7. D will be 3. E will be 0, and F will be 2.
Did you?
Let's have a look. 4 and 7 is 11. You put the 1 there, carry the 1. 1 and 8 is 9 plus 3 is 12. So you put the 2 there, carry the 1. 1 and 9 makes 10. Put the 0 there, carry the 1. And you land up with 6021. Absolutely correct. Well done.
Well done.
Was that a tough one?
Yes.
It was quite a tough one, but you see a little bit of detective work and some common sense, and you could actually knock out all the things that it couldn't be, and you were only left with 1 or 2 choices. So you could have gone with the 1 and tested, and if that didn't work, then you could have gone with the other one. So that's not too bad. All right, have we got time for another one?
I've got to go in 5 minutes, so if you've got another quick one, that'll be great.
Let's see if I've got a quick one for you. Okay. Okay, you won't be able to give me the answer today, but you can think about it.
Okay.
Most people would like to think that when they finished working, they retire at an age of about 65. Okay? And
Okay.
65, basically what that means is that you've put enough money away by the time you reach 65, so when you stop working, you live off the money that you get every month from your retirement. But unfortunately, that doesn't happen that way anymore, and I don't think anyone can afford to retire anymore. That's the reality. But now, if you could retire at 65, your boss says to you that he wants you to retire when you are 2 billion seconds old.
Ooh.
Does that mean he wants you to retire at 65, or younger than 65, or older than 65? So the big question is, how old is 2 billion seconds?
Are you using the American or the short or long
The South
standard
African,
version of
the
billion?
traditional. And if you're not sure, I'll just write it out for you. That a billion looks like this. Okay, a billion looks like this. Can you see that?
Yeah. It's 1,000 million.
It's 1,000 million. So if you have $1 million rands and you put them into 1,000 piles, you've got $1 billion rand.
Yeah.
So now how do we work something like this out? It's a tough one.
How are you going to work out what it is? Divide by 60 to get minutes, eh?
Yeah.
Okay. Remember, this is going to be 2 billion seconds. Not 1 billion, 2 billion seconds.
So 2 billion
so you're
seconds.
Gonna, yeah, this is what
Well, I suppose if you work out how old 1 billion is, you double it.
Yeah, true. So you first divide by 60 and you get minutes, eh? Then what would you do?
Now this is
Well,
one.
hang on. Were you saying that
Second.
Divide by.
if you divide by 60, you've changed seconds into minutes?
Yep.
And what's the next units of time? 60 again, and you're going to get?
Very good.
Hours.
Hours. Good. Then?
Divide by 3.
24, and you're going to get?
A day.
Days. Good. Then divide by?
65.
But clever. I'm glad you didn't say weeks or months, because then you'd have a problem. But 365, all the years have 365. Okay, so how are you going to make the adjustment for the leap years?
That's a tricky one. I'll give you a clue. It's a fraction.
You think about an extra day every 4 years?
Yeah. Every 4 years, you have an extra day. So what happens in the first year? You're not going to have an extra day, but you're going to have an extra portion of a day.
Yeah.
What fraction will that be?
Exactly.
Correct.
Exactly. You remember from if you do
65.
What do you get at time? Remember when we did decimals earlier in the term? What's a quarter as a decimal? So when you divide it, you're going to divide by 365, 25. Okay? Yeah.
Okay.
Then you're going to get the same.
That's how many years, and then obviously you'll work it out. But now the problem is that most calculators can't hold a billion on the actual calculator. So what I told my students to do is work with 1,000,000 or work with 1,000, and you do all your calculations, and then you multiply back. So if you're going to divide it by 1,000, you're going to have 1,000,000, but then whatever your answer is, you multiply it back by 1,000 to get it back to how many years you would be. And you're going to have to let me know for next time. Are you able? Well, I mean, Ms. Goldberg, you can let her know if she made it or not.
Okay, Kiara, can you work on that in the next day or two, and then let me know how old you're going to be when you're allowed to retire? Or how old I can be when you're allowed to retire.
All right.
Maybe I can go tomorrow. Thanks so much, Steve.
Thank you so much for joining us today. Have a wonderful holiday, and the 30th is when you're starting again.
Yeah. Thank you so much.
Next term, we're going to try and do a little visit.
Oh, that would be amazing.
So then we'll try and do, like, instead of, like, we'll try and maybe do it. When is your school assembly normally?
It's normally on a Thursday at about 9:45.
Okay, so maybe what I need to do is come up on a Thursday morning and come and take over your assembly for a little while.
That'll be perfect. If you need a place to stay, you can always stay with me.
Okay, well, thank you. But I'm sure, I mean, it'll probably be one of those days where I come in the morning, spend the day there, and then fly out at night because I've got to be at work the next day. But we'll make a plan. I'll come and do some crazy things with you guys next term. All right.
Super. Thanks, Steve. Okay,
Excellent.
cheers. Thanks so much.
Okay, bye-bye. Bye-bye.